All right, perfect. So we should be good now. All right. Okay. All right, math family. So we're sorry about that, man. I don't know what happened, but we got a little bit the live stream was not connected. So hopefully we're connected now. We're good. All right, so let's jump back in into this real quick. All right. So we finished off with order of operations absolute value. Now we're going to be talking about combining like terms. So combining like terms is something that you are going to see throughout the entire algebra 1. So let's just do a few examples. All right. All right. So when we look in our first example, right, like terms are just basically any type of terms that are similar. So an example of this is 3a and 5a. They both have a's and we're able to combine to get negative 2a, right? So that is our first simplifying or combining like terms. When we get to our next example, oops, and I wrote this down wrong. My bad, guys. Let me rewrite this. All right. So a common misconception with like terms too is that they have to be the exact same. So for us to add anything to 3xy, that other term has to have x, y too. It can't just have the x or the y. So when we look at this example, these are the only two like terms that we have. So when I add just the coefficients, I'll get negative 17 x squared. And since these other two terms don't have like terms, they stay the same. So plus 3xy minus 3, this is our answer. Same thing down here. All of these do have AB. But if we look at this term right here, this is AB squared. So if we wanted to add these two terms to this middle term, it would have to have AB squared. So as a result, we can't do anything with it. So we'll have, let's do this first. Negative 7ab minus 5ab squared, right? Yeah, I think that's correct. Yeah, that's correct. All right. So when we're thinking about like terms, guys, just make sure that the variables are exactly the same as well as the exponents. If you don't, there's a big chance that you can get these problems wrong. All right. Now we're gonna go back to the distributive property because I really want to talk about the foiling method, and we want to do another example. Okay. So in this example, what we have, they're gonna give us, and let's go through this first, right? So this is what we're typically gonna see with the distributive property, right? They're gonna give us two expressions, and we're typically going to distribute and combine our like terms. So it's like 2 and 1. So after we go through, right, I multiply 10 by x, we have 10x minus 20. Right here, you don't see a number. Just place a negative 1 in front of this negative, and just switch the signs. So this turns out to negative x plus 4. Now at this step, we could combine our like terms to get 9x, right? Negative 20 plus 4 minus 16, and that should be the correct answer. Perfect. Now, in our second example, right, let's look at another one. Let's say they gave us this. So we have 4x plus 7, and we're going to combine that with 2x minus 5. So typically when you see distributive property, you're always going to combine like terms. Remember, distribute just means to multiply. So we get 4x plus 28. We multiply 2 by x to get 2x, 2 and negative 5 to get negative 10. Combine my like terms, 6x. 28 minus 10 is going to give me positive 18. And that is my answer. Now, I was talking to you guys about FOIL, and we're going to get into that. There's so much stuff to talk about. But let's say we had something like this, right? Because I like to use the box method. So if you're someone who is not good with foiling, right? First, outer, inner, last, and I'll explain it later, right? This is what we could do. So let's say we had 7x plus 1 multiplied by 2x plus 4. So using that box method, 7x and 1 go on top because we got to keep what's in parentheses together. And then 2x and 4 go on the side. And then I just multiply. So this is an easier way to help you out with this. So 14x to the second power, 2x and 1 is just 2x. 4 times 7x is 28x. And 4 times 1 is 4. Now, when you do this method, the beautiful thing is those diagonals are always going to be like terms. So it kind of helps you to add them. So 4x squared plus 30x, let's make sure this is right, yep, plus 4. All right. So when we talk about distributive property, we're talking about combining like terms. These are some of the important skills and terms that you're going to need to understand when we're talking about Algebra 1. Now, after we kind of take a break from expressions, we're going to dive into equations, all right? So there's different types of equations, one step, two step, multi-step, and guys, just understand they're all the same steps to solve. They're just different amount of steps. So let's look at this, right? So let's say we had x plus 20 is equal to 9. One step equation. Why? Because after we subtract, we get our answer. So x is going to be equal to negative 11. One step equation. Two step equation is just two steps, but we're going to skip that and we're going to go into multi-step equations. So let's say we had something like this. We have 4x minus 10 is equal to x plus 3x minus 2x. So guys, let's understand the overall objective when we're solving equations is to get the variable x, y, a, b, doesn't matter, and the number without a variable on opposite sides of the equal sign. So number one thing you want to do here is just let's clean this side up. So this is going to give me 4x minus 2x. So this is just 2x right here, right? This side stays the same because there's no like terms, but there are like terms on the opposite side. So I'm going to subtract. So this cancels out on this end. Do the same thing here. Negative 10 is equal to negative 2x. Once I divide, so I could get x absolutely by itself, we know x is equal to negative 10 divided by negative 2, which is just positive 5. Okay? All right. So when we think about that, one of the biggest things with equations where students may be confused is when we talk about infinite solutions versus no solutions. And just understand, this is just the amount of answers we have. Because the first two you just seen was what? This is just the answer of 1. Okay, I got you. I'm sorry, guys. It's hard to see some of the comments, but I'll slow down for that one person. All right, so let's say we're talking about the infinite solutions, no solutions, right? What does this mean? We're just talking about the number of solutions. So what I just did was one solution, right? So when I get over here to no solutions, that just typically means that there is not an answer, that we cannot solve the equation. And I'm going to show you how you know when you get to that point, okay? Because I think that is where students kind of misunderstand. When is it a no solution as an answer? So, all right, we start off, right? Can't do anything on this side. We leave it alone. This side, we need to distribute. We do not, this is a trick, do not subtract. We have to multiply first distribute before we even worry about 2 minus whatever. So this side stays the same, right? Equal to 2 minus, and after we distribute, we're going to get negative 7x minus 42. Just multiply negative 7 times x, and did the same thing with negative 7 and 6. Now here, let's clean up. Positive 2, negative 42. And anytime you get confused with positive and negative numbers, the trick is I think about money. I'm going to be honest. So this is what I mean. So let's say we're here, right? Your friend has $2, but they owe you 42. So after they gave you the $2, how much are they in the hole? They still owe you what? $40. So this is just negative 40, right? We have negative 42 plus positive 2. We're just subtracting. So 2 minus 2 is 0. This stays the same. We take the sign of the larger number. The larger number was negative. But if that doesn't work, think of money. Money always helped me. All right, so now we're here, guys, and understand we need to have the variable on one side, exponent on the other. So what happens is I start off with my variable. I say, okay, let's combine variables. And what happens is we notice the variables cancel out on both sides. What are we left with? Negative 38 is equal to negative 40. So we all know that this is not true. And because it's not true and the variables cancel out, this is no solution. We can't solve that. Negative 38 and negative 40 will never, ever be the same, right, in value. So we could just put a slash through the equal sign to let us know it's not equal, or we could do this for no solution. Or if you're just old school and you want to be careful like me, I'll just write it out on the paper, no solution. I don't think your teacher will be mad. Okay, so that's a no solution equation, okay? Now we go back and I want to show you how the equation or how the answer will look when it's infinite solutions, okay? So we have an equation like this. All right. And just bear with me, guys. I'm trying to check the comments just to make sure that you guys are with me, okay? All right. So it doesn't look like we have any new comments. So when we're right here, guys, something that I've always seen, and this is just if you're moving too fast. Yes, we are going to distribute, but not to 2x. We only distribute to what is inside the parentheses next to this value. Anything outside, we're not going to touch. So try not to make that mistake moving too fast to the problem. So we go through negative 3x minus 15. This stays the same. 2x stays the same. Is equal to negative 15 minus x. These are the only two like terms. And I'm always going to tell you, before you move things from one side to the other, just simplify first. So money again, hey, your friend owe you $3. They only had 2. So how much they owe you? $1, right? All right, so that's negative 1 minus 15 is equal to, and what I'm going to do here, and matter of fact, no, let's go back so we're on the same page. Let's just write it in the same. So we have negative 15, right? After we combine our x's, we get minus x, right? Is equal to negative 15 minus x. Let's say here you're confused. You're like, yo, whoa, it looks like the same thing. You could stop here. But if you want to make sure, let's say we combined our x's, right? Because we want an x on one side. Both the x's cancel. However, the difference here is what's left over. Negative 15 is equal to negative 15. So this is what we're talking about when we say infinite solutions, right? And you'll see a sign, something like the infinity sign, right? And all this is letting you know is what? Any answer we plug in for x, both sides of the equation is going to be equal. So I just want you guys to know that, all right? Okay. So now we're gonna be leaving equations now, kinda. And we're gonna go into our other topic. And this other topic involves fractions. I'm so sorry, guys. Don't be mad at your boy. So just remember, we're talking about proportions, all right? So when we talk about proportions, we're 9 times out of 10 going to see a fraction. And what we want to do is to figure out what is the unknown number so that both of these fractions are equal. Okay, that's typically the whole goal. And I'm going to show you two different versions of this because typically students get this right, but the second version they struggle with. All right, so we're just going to cross multiply and solve for x. Okay, so we have 5 by 12, so we get 84 is equal to 8 times x. Now this turns into basically a one-step equation. How are we going to figure out what x is? We're going to divide by 8. So now 84 divided by 8 is going to give me 10.5, and this is what x is equal to. And if you plug it back in and divide the top number by the bottom number, you're going to figure out that that decimal we get is going to be the same. And let's just check this Facebook real quick. All right, so what they like to do too, and this isn't hard, it's just that there's more things involved. So let's do this. X plus 1 over, make sure I write this right, x minus 2 is equal to 4 over 7. So look, if I'm your math teacher, I'm going to tell you this. If there's more than one term, right? This is one term, one term, one term, one term. So these are two terms. If you want to get this right, just trust me. Put a parentheses around it if there's more than one term because we are going to distribute. So you already know cross multiply, right? Exactly. So we cross multiply. Let's set it up. So we got 7 times what? X plus 1 is equal to 4 times x minus 2. Now that you set this up, this is solving equations. This is just solving equations. So we distribute, right? Distribute, meaning we multiply 7 times x to get 7x, 7 times 1 to get 7, and that is equal to 4 times x, which is 4x, and 4 times negative 2, which is negative 8. So now, like I said, guys, set up the proportion by cross multiplying. It turns into a multi-step equation. So as we're here, remember, variables on one side, constants on the other, and we could subtract 7 on bring it on this side, or we could subtract 4 and bring it on this side. As long as the variables and constants are on the opposite side of the equal sign, we are good. All right, so here we go. 3x plus 7 is equal to negative 8. When I subtract 7, we have 3x is equal to negative 15. And you guys know 9 times out of 10, the last step is always to divide. If you see something like this, 3 times something or a number times x is equal to something, we're always going to divide. So now I divide, x is equal to negative 15 over 3, which means x is equal to negative 5. And that is it. And if you want to double check, plug x back in, add it to 1, plug the x back in, subtract 2, divide that, and see if it's the same value as 4 divided by 7, just to self-check, okay? Okay. All right. So now we're going to move from proportions, and we're going to get into absolute value. But this absolute value is not like the one we just had before. This absolute value is we're going to actually, it's going to be an absolute value equation, okay? So let's say they gave us something like this. All right, so there's typically 2 rules that I tell students. One, make sure the absolute value is by itself, meaning there's no other numbers being multiplied or added to the absolute value, right? After that, make sure that what it's set equal to is positive, because we cannot take the absolute value of a negative number. And they're going to always try to trick us with that. I'm just telling you from a teacher standpoint. Okay, so beautiful thing. When we get it here, meaning the absolute value is by itself and the what it's equal to is positive, we just create 2 equations. The first equation is this without the absolute value brackets. X minus 8 is equal to 5. Equation 1. Equation 2 is the same exact thing, but now we set this, what the equation is equal to the negative part of it. And what I mean by the negative part of it is just make the number negative. So negative 5. because we're now going to get two different answers. So I just simplify an answer. So x is equal to 13, right? Or when we add 8 on this side, x is equal to positive 3. So when we're talking about absolute value equations, this is what we're talking about. And this is not the only example. I got some more for you guys, okay? All right. So in the second example, this is what you're typically going to see. Because I know us math teachers, we do the easy peasy with you, and then after that, you go home and you have this crazy problem to do. So this is what you will see, and I'm going to walk you through it. All right. So all right, number one, absolute value, or what the equation is equal to, is positive, so we're good. However, the absolute value is not by itself. It's being multiplied by 4, and we're subtracting 1. So this is what we're going to do. We're going to add 1 first, right? Everything else stays the same, right? But it's still not by itself. Why? We're multiplying by 4. So the opposite, or the inverse operation, right? The opposite operation is just dividing. Bam. So now we got the absolute value of 2x minus 3 is equal to 3. And for my follower that commented, I hope I slowed down for you. All right. We're going to post this video up for you if you want to watch it later. But we did see your comment, and we appreciate you for commenting. So now at this step, right, we have the absolute value by itself. The equations is set equal to a positive integer. So now we could create our equation. The first one, just drop the brackets. 2x minus 3 is equal to 3. Let's solve. We add 3 on both sides. 2x is equal to 6. Once I divide, which is typically the last step, I'm just saying, right? X is equal to 3. Let's check the notes. Boom, that's right. Now the second equation, same exact thing, but we're going to make it negative, right? So 2x minus 3 is equal to negative 3. You guys know, solving a regular equation. So I add 3 on both sides. 2x is equal to 0. We could just say that x is equal to 0, but I'm going to be real. Some of your teachers want to see you guys do the work. So just do the extra step. Just do the extra step, right? We know 0 divided by 2 is just 0. But this is typically how we solve absolute value equations. But before I go on to the next section, I want to show you an absolute value equation where we won't be able to solve. And you know, hey guys, I really appreciate your comments, because I'm nervous up here. But I love this math, and I like making it so easy for you that I will try my hardest not to act like I'm nervous. But thank you guys for your comments, and that's why I do it, man, because I found out I'm pretty good at making it simple for people. All right, so right now, right, absolute value is positive. We good. But I mean, the equation said equal to a positive value. But when we look here, the absolute value is not by itself. So we go in, right? We're killing it. We're understanding, we divide by negative 4. Now we get the absolute value of x plus 1 is equal to negative 4. And this step right here, we need to know no solution. Why? Because that absolute value can't be negative. It can't. So we can't do this. There's no solution. That's it. Don't try to understand it more than that. All right. So we talked about absolute value equations. We're going to jump into absolute value inequalities. And yes, we are going to graph it. All right. So let's get into this. Don't mind me. Just take a sip of water. All right. Ooh, how do I want to do this now? All right. So When we get over to absolute value inequalities now, right? We're typically going to have two situations. We're going to create an equation where we have an and inequality, meaning that the inequality runs into itself, like the graph is attached, or we have something where, oops, not like that. Let me see, what's the best way to put this? Yeah, so x is greater than a or x is less than b, and then the graph is going to go in opposite directions. So I just need you to understand that these are the only two scenarios you really are going to see. Graph going towards each other, graph going away from each other. Now, how do we know which one is which? Well, it typically depends on the problem, and this is what I mean. So let's look in problem number 1, right? So anytime we have greater, and this is how I teach it, greater than, greater means we're going to have two separate inequalities going in the opposite way. Greater, that's how I teach my kids. A lot of them learn it. So how does that look like? So they give us something like this, right? Absolute value of 2x minus 1 is greater than 9, okay? And at this step, we keep, because it follows the rules, right? The absolute values by itself, this is positive. The first equation is just this, okay? So I have 2x minus 1 is greater than 9. I add 1 on both sides. 2x is greater than 10, right? Let's just add this here. So now I know x is greater than 5. I did skip the step of dividing, but you guys know I divided, right? Or then we go to the second equation. In the second equation, the absolute value and, or not the absolute value, but the inequality sign and the number flips. So now, and let's switch colors so this pops out, man. I know it's not always easy to see. We have 2x minus 1 is what? Not greater than, but less than -9. Yes, you have to do this with all the problems. The first one, just keep it the same. Drop the bars, keep it the same. The next one, flip the inequality symbol and the number, okay? So at this step now, we're doing the same thing. Plus 1, 2x is less than -8. We divide by 2 on both sides. Now we get x is less than -4, right? So these are our two answers. So you guys are probably saying to me, all right, Peters, we got the answer. What's next? We got to graph this bad boy, right? So let's go back and we're going to graph. So let's erase some space. I'm going to do a real quick graph, nothing too pretty. So here goes my number line, right? And don't be like me. Make sure you label it. I'm just doing this real quick. So we have -4 and we have +5. So this says x is greater than 5 because it's just greater than, right? Or less than, meaning it's not or equal to. That means on the graph, we have a open circle, right? And we're going to shade where x is greater than 5. So to the right, this is how it should look. Remember, I told you the OR graphs go in the opposite way. So if they're going towards each other, you know you did something wrong. X is less than -4, right? We know zero's in between these, so that means it's going away from 0 if it's less than. So bam, here we go. Now something else that's important here is called interval notation, which is just another way to express the answer. So we read the graph from left to right. And because we can't label all those numbers, we use this sign called infinity, right? Negative infinity, positive infinity. So if we're coming way out from the left from 1,000, like I said, 2,000, 3,000, we can't label all those. So we say what? Hey, we're coming from negative infinity to where? -4. Now, if you have an open circle, that means you're going to have a parentheses around the number from that number line or your answer, right? So this is why we have parentheses. If it was less than or equal to, we would have a bracket around 4. So I just want you guys to understand that that's what determines whether it's a bracket or parentheses or whether it's an open or closed circle, the inequality sign itself, okay? And then we're going to put this u. It's just saying this is joined with because there's nothing here. Where does the graph pick back up at? 5, parentheses, because that's an open circle. And where is it going to? 6, 7, 1,000, 100,000. Can't list all those numbers. So we put infinity, and these infinity symbols will always have parentheses around them because we cannot include them. That is a concept you must understand. So if you see anything with a bracket around negative infinity, this is what we're gonna do, right? Let's say we had this problem. And you have to be very mindful because there's so much tricks they try to throw in here. All right. And before I do this, let's just check the comment section real quick. Okay, so all right, so we're coming back now, right? And this right here is kind of a trick. I know it used to get me. We see the negative, we think no solution. No, no, no. That's a trick. Make sure you simplify first. Because once we do this, right, this is going to turn positive, but there's also one more trick. So anytime we divide by a positive or a negative number, right, this absolute value sign is going to flip. So in this instance, we need to flip this. And what happens now is we're going to create that and inequality, meaning it's going to run, it's a compound inequality that run towards each other. So when we look at this, right, typically what I like to do is just tell my students, hey, just take your answer, put it on the other side, right? So both sides the same, but this is now -6. Let's drop our bars. Subtract 2, because we want to have x in the middle. We want to keep that in the middle by itself. And that should be our answer. The way we read this, x is greater than -8 and less than 4. Okay? So when we go to graph this, remember, they're going to run into each other. So we have -8 here, 0 here, 4 here. So we said what? We said that x is what? Greater than 8. So open circle, we know it's greater, it's going this way. X is less than 4, open circle is going this way. So this graph should run into each other. Now the interval notation for this is 100 times easier because it's literally just these two numbers, literally. So we'll put -8, comma 4, open circle, right? So that means parentheses. Now, if this was a closed circle, it would be the same thing in the sense of the same numbers, but instead of a parentheses, we would have a bracket, all right? Just to give you an example, if it was less than or equal to, okay? All right. Okay, so what we have next now? All right, so the next part that we're going to go into is we're going to talk about functions now, all right? We're going to talk about functions. And let's see. Okay, so we don't have any new comments. Looks like we slowed down. Okay. All right, so when we get back here now to functions, so we need to know this. We have x and we have y, and we need to know vocabulary. So because we're talking about what? Formulas, scales, terms. So when we see x, this is our domain. All right, they're also going to call the domain the input, and they're also going to call it the independent variable. So anytime you see any of these, just understand they're code switching. They're trying to confuse you, but it's the same thing. Okay. Now we get over here to y, which is our range. Output, dependent variable. I almost forgot that. Wow. All right, so dependent variable. If I spelled anything wrong, this is why I teach math. Just leave a joke in the comments. Okay. So one way they typically ask us about domain is something like this. So they'll give us a few points. Okay. So what points will they give us? They'll give us something like, well, not even points, ordered pairs. So they'll give us something like this, and they're going to ask us to identify the domain and range. See, I don't know what your teacher tells you, but if you never want to get this wrong, right? We know X comes first, Y. I would just do this, just real quick. Just write the variable over it, right? So I know when we talk about my domain, and they typically want you to put it in order from least to greatest, right? So when we talk about domain, let's see, we have just the X values, 1, 3, 5, and 7. That's it. Now we go back, we list the range. Least to greatest, okay, so we have what? That was ugly, I'm sorry. 0, 2, 3, and 4. That's it. So if they give you ordered pairs and they ask you to list your domain and range, this is exactly what you would do. Okay. Now, another question they like to ask you guys when we're talking about functions and domain and range is this. And it's just so funny because it's all a puzzle, it's all a trick. And so this is what I mean. So they give us the function, right? And understand y is equal to negative 2x plus 1. When we get into function notation, they just substitute. So now we have f of x, but it's the same thing as y. So let me hold on. There's something I wanted to. All right. So let me just break this down for you so we're on the same thing, right? So x is our input, right? This is just our function notation or name. Let's just put function name, f of x, g of x, h of x. And then right here, when we simplify, this is just our output, okay? Just so you know. So now when we get back to this problem and they say to us, this is what they're gonna do. They're gonna say, hey, they want us to find, let's erase some. We got that. Hopefully you guys got that. Let's say they ask us now to find range when domain is, and they give us numbers, right? So they say domain is equal to, they give us a solution set, -1, 4, 5. How do we solve this? We just plug it in. All right, the answer we get is our range. So let's say we take the domain of -1, right? So we have f of -1 is equal to -2 times -1 plus 1. All right. So f of -1 is equal to what? 2 plus 1, which is just 3. So if they're asking us for the range, the answer when x is 1, the answer is 3. And if we go back and do the others, it's the same exact thing. We're just switching the input, what x is equal to. So let's say we go back and do the same thing, f of 4. So now we plug 4 into the function, right? And when we plug it in, what do we get as an answer? So f of positive 4 is equal to -8 plus 1. So we know f of 4 is equal to -7, right? So if they were asking us for our range and we just stopped right there with those two answers, I would put my range is -7, 3 as my solution set. So this is what they mean when they're asking us for domain and range, okay? And another thing that they like to do, which is it's kind of silly, but it's very similar to this, and you can get confused, is evaluate the function. Okay, so let's say we switch this up and they gave us this function now. Let's go in black. So they gave us the function f of x is equal to 2x minus 7, and they tell us to find or evaluate f of 5. So evaluate this means to simplify, right? Or find the answer. So plug it in. 2 times 5 minus 7. Once we evaluate, right, we're going to get 10 minus 7. So we know f of 5 is equal to 3. And another way to say this is hey, when we plug in 5 into this function, our answer, our output is going to be 3. All right? All right. So we're going along so well, guys. And like I said, check in the comment section. Really appreciate that you guys are on here with us today. We hope that the pace is a lot better for you all. All right. So this is something else they like us to do when we're talking about functions. So they want us to get the zeros of functions, and this is kind of it's almost similar to factoring, but not necessarily. So when they ask us for the zeros of functions for linear equations, meaning there's no exponent, what we do is we set it equal to 0. So now f of x turns into 0, and our goal is to focus on solving for x. So I would add 15 on both sides so that the variable and constant are on opposite sides. So 15 is equal to 5x. Once we divide, we know 3 is equal to x. So if we were graphing this or trying to figure out what was the x-intercept for this function or something like that, this is how we would do it. That's what we're talking about, finding the zeros of the function, all right? So when y is 0, this is where this function is going to cross the x-axis at 3. So this is what we're talking about when we're talking about this specific rule, okay? All right, so we're going along now, and I'm not going to lie, we've been on here for a good while. Oh, cool. Appreciate you guys for logging on today. If you have any questions, comments, we're looking at the comment section, just bear with us, be patient, we'll try to answer. All right, so we're going to slope, right? So when we go to slope, there's two versions. So we have standard form, right? ax plus by is equal to c. And then we have slope intercept form. Y is equal to mx plus b. So we know slope intercept form is what we typically use to what? To graph lines, all right? But what I want to focus on here is just how to switch from one form to the other. So let's say they gave us this equation, 6x plus 7y is equal to 7. So if we wanted to switch from one form to the other, the goal is to get y absolutely by itself. So 10 times out of 10, you're going to probably either subtract or add your x. So this is positive, we're going to subtract it. Remember that these two are in like terms, so we can't combine. 7y is equal to, and keep it in this form, meaning keep the slope first or in front, okay? Bam. Now, just understand we didn't get y absolutely by itself, so we go back and we divide everything by 7, or whatever number's in front of y. So we have negative 6, 6 over 7x plus 1. Now, if we were to graph this, we could use the y-intercept of 1 and then use our rise over run to get the second point, all right? Now, let's say we have a different example, and in this example, we had something like this. 2x minus 4y is equal to 12. We could definitely put it into slope-intercept form, but before I do that, there's another method what we call graph by intercepts, okay? So when we talk about graph by intercepts, I don't even know why I'm drawing this, but we make one variable 0. So let's say I made y 0, so it's basically gone, right? Because 4 times y is 0 doesn't change. So we're left with 2x is equal to 12. When we divide by 2, we know x is equal to 6. So I will go down here when x is 6. Let's just say it's right here. We'll plot that point, right? That's the first point. Yep. Then now let's say we go back and we do the same thing. So the x is gone. We made it 0. We're left with negative 4. Y is equal to 12. Now guess what? Divide by negative 4. Divide by negative 4. Y is equal to -3, which would be somewhere down here, right? So we just graph by the x and y intercept, and we could draw a quick line real quick. So let's say if we did do the slope intercept form. So let's say I subtracted 2x, and now I'm right here. -4y is equal to -2x plus 12. After I divide by -4, divide everything by -4. Man, I'm sorry. I'm all over the place, guys. So excited tonight. We're going to have y is equal to, make sure I get this right, yep, -1/2x minus 3. So when we look at that y-intercept, right, same thing, -3, -3. We have a, hold on. Oops, I knew this was wrong. All right, this is a positive slope. Yeah, we have a positive slope, which this line is positive. So just understand there's more than one way for us to graph our lines. Now, something else I want to touch on when we're talking about graphing, right? We're talking about slope intercept going from one form to the other. Let's talk about when we have something that says x is equal to 4 versus y is equal to 1. Okay, so let's check the comment section before we get into that, and then we're going to do that problem. All right, so when we have these guys, these are special cases in graphing. And the reason why is when you have x is equal to something or y is equal to something, you're either going to get a horizontal or a vertical line. So anytime you have x is equal to something, we are going to have a vertical line. So x is equal to 4. Let's say 4 is right here on the number line. That line is going to be this. This is how we graph x is equal to 4. So if we have if we're talking about slope, linear equations, same thing, right? Linear equations, this is what this is. X is equal to 4, vertical line. Y is equal to 1, horizontal line. And the trick is, right, let's say this is y is 1. This would be y is equal to 1. And I want you just to use the x and y axis. So if it says y is equal to, remember, y-axis runs left to right. So hey, y is 1, y is 2, 3, 4, 10. You know it's going to be a horizontal line. If it's x, we know the x-axis is what? It runs vertical. So if we just have x is equal to something, it is a vertical line, okay? I just want to make sure I tell you guys that. All right, so we talked about switching from standard form to slope intercept form. We've hit how to graph horizontal and vertical lines. What else is new for us? So we are going to graph one of these, but I'm saving that towards the end of this section. All right. So let's say they want us to write the equation of a line, right? So that means we have to use the point slope formula, which is y minus y1 is equal to m times x minus x1. Just did a video on this. I'm going to link it down below for you guys, right? So they do that, and then they give us 2 points. 2, -1, and -4, 11. So how exactly do we do this now? Well, first off, we have to find the slope, right? So we got the point slope formula. This is when we know the slope in one point that the line passes through. That's the criteria. But also another thing else, sometimes they'll give us the problem and we have to determine the slope. And remember, the slope formula is m is equal to y1 minus y2 over x1 minus x2. So that's the slope formula. Another very important formula you have to know. You'll also see this called rate of change when we get into quadratic equations. It's the same thing. All right, so I just labeled this because I don't want to overthink. Now we substitute. M is equal to, so this is going to be my x1, y1. So we'll start there. -1, no, yep, -1 minus 11. Make sure I'm starting off right. Yep, perfect. Over 2 minus -4. And just make sure you don't get fooled with that double negative because they always do it. So we get negative 12 over 6. Once we simplify, we know m is equal to negative 2. All right. So now that we have our slope, we can use either point for this equation, right? Either point, it doesn't matter. I showed that in that video that I just did on the point slope formula. So I'm going to pick the one with those smaller numbers, right? So we have y minus negative 1, right? Because that's the point we picked, is equal to m negative 2 times x minus 2. And for us to create the equation of the line that passes through these 2 points, we're now just going to simplify this. So we get y plus 1 is equal to negative 2x plus 4. Let's double check the notes because you guys think I'll be playing when I say I'm nervous. Let's see, is that right? Yeah, it is. Okay. All right, so now we go through and we're going to have y is equal to negative 2x plus 3. We subtracted 1 from both sides just in case you guys were wondering. All right. So this will be the equation of the line that passes through these both points. Just make sure you get the slope first. So something else that they like to do, and this is probably the easier version or the more simple version, is that they're going to give us a point, right? So they say, hey, this equation passes through the point 5, negative 2, and it has a slope of negative 1. And they say to us, what is the equation? So we're going to use the same formula, all right? We got the point. So y minus negative 2 is equal to what? Negative 1 times x minus 5, okay? Whew. And at this step, we have y plus 2 is equal to negative x plus 5. Yep, negative x plus 5. So then when we simplify by subtracting 2, all right, just double checking. Y is equal to negative x plus 3. All right, and I believe that should be correct. Yeah, that should be correct. That should be correct. Okay. All right. Let's see, what else do we have? All right, so math family, I don't know if you guys are still with me, but if you're still with me, man, just drop a comment or a like so I know. I know this is a long stream. I'm normally not on this long. All right, so what we're going to do now is we're going to graph. I just want to show you guys how to graph one of these. And depending on who's with me, we'll probably keep on going or we're going to come back with part 2 next Wednesday. All right. Like I said, if you're here with me, man, appreciate you guys. Really hope this is a helpful live stream for you. All right. So let's say we have this and they want us to graph. Get my little ruler out so it looks neat. All right. So we drew our coordinate plane, right? So let's say for the video's sake, all right, we're gonna switch it into slope intercept form. So we have 2y is equal to negative x plus 6. I divide by 2. I get y is equal to negative 1/2 x plus 3, right? So what does that mean? Well, let's think about it real quick, right? So that means my y-intercept is probably going to be 0, 3, right? But then we need to find an x. So just because we're on the board, I'm going to do it by intercepts. So look, 2y is equal to 6. When I simplify, y is equal to 3. So when x is 0, y is 0, x is just equal to 6. Okay? Let's see. Yep, when y is 0, x is just equal to 6. Let's make sure it's right. Let's make sure. Yeah, that is correct. When y is 0, let's do it. Let's just do the math. I'm trying to do this in my head. So x plus 2 times 0 is equal to 6. So, yep, x is equal to 6. So another way to do this would also be to graph by intercepts. So just a quick example, guys. Typically what we'll do is use the rise over run to get to our other point. But because we're using the board, just going to graph by intercepts, okay? And I believe that should be right. I don't think I made a mistake on that one. All right. Let's see what's going on in the comment section real quick. Yeah. All right. All right, so what we're going to do is we're going to finish off these last two problems with perpendicular and parallel lines. And next Wednesday, we're going to pick up with systems of equations, and we're going to touch on polynomials, exponents, rational and radical equations and expressions. But let's say that we were talking about, we're still talking about linear equations, right? So let's say they gave us the equation y is equal to 5x plus 4. And let's say that this line passes through the point 1, -2, and they want us to come up with a equation for a parallel line. So when we think about parallel lines, they're always going to have the same slope. So we know the slope already, right? We know the slope, we know the point, we know the point slope formula that we have to use to create the new equation. So all this is about is just now simplifying. So I go through, we have y minus -2 is equal to what? 5, right? Because parallel lines have the same slope, similar slopes, right? X minus 1. Yep, that's absolutely correct. So we have y plus 2 is equal to 5x minus 5. Once we simplify by subtracting 2, we'll have y is equal to 5x minus 7. So this is the equation for a parallel line, and it's going to be parallel to this line right here. Okay, hold on, let's see something. Yep. Okay. Just gotta make sure. All right. So now let's say if this was the same equation, same point, but now they said to us, Peters, we don't want a parallel line. We want a perpendicular line, or the equation for the perpendicular line, right? So same exact process. The only difference is now is the slope. So the slope, right? When we talk about the original equation, the line that's perpendicular to it is going to be a negative reciprocal. So if we turn this into a fraction, took the reciprocal, right? It would be 1 over 5. And then we're talking about the negative reciprocal. So if it was positive, it turns negative. So this is the new slope we're going to use when creating the equation that's going to be a perpendicular line, right? So now we go in and we substitute, right? We're talking about the same exact point. So we're talking about y minus -2 is equal to what? -1 over 5 equal to -1 over 5x plus 1 over 5, right? At this step, what we're going to do is now subtract 2. So y is equal to -1 over 5x plus 1 over 5 minus 2. Now remember, we're combining fractions, so they have to have the same denominator. So luckily for us, right? Make sure I said this right. Yep. 10, 10 over 5 is the same thing as 2. So we're going to switch this out, right? We got the common denominator of 5, and we know this is the same value. 10 over 5 is going to give us 2. So now we simplify. Y is equal to -1 over 5x. Yep. minus 9 over 5. And this is going to be the equation for the perpendicular line. Okay. So I know I kind of kept you guys on here for like an hour and a half. We are going to end the live stream for this week, but I'm going to come back and we're going to pick up on systems of equations, and we're going to talk about the second half or the more challenging aspects in algebra. So please make sure that you guys stay tuned. We appreciate you guys for joining us on our live stream today. And thank you so much. Hit this like button for us. Comment down below if there's any specific topics you want to see next week that we didn't touch this week. And we thank you guys so much for joining us today on our live stream with Algebra 1 with Mr. Peter.